Welcome to Summarize Science, where we look at the latest breakthroughs in technology. Today, we are diving into a new research paper about panoramic affordance prediction. To understand this, first we have to think about affordance, which is a fancy way of saying what actions are possible in a specific environment. Most AI today relies on a pinhole camera model, which gives them a narrow field of view. This creates a kind of tunnel vision, where a robot might miss important objects just because they are to the side or behind it. To solve this, the researchers propose using 360-degree panoramic imagery to give robots a holistic view of their world. They introduced a massive new dataset called PAP-12K to help train and test these systems. It features over 1,000 ultra-high-resolution images at 12K quality, which is way beyond what most standard datasets offer. The dataset includes 12,000 annotated pairs of questions and answers to help the AI learn how to interact with scenes. Panoramic images are great for seeing everything, but they come with unique challenges like geometric distortion. Think of how a flat map of the Earth looks stretched at the top and bottom. The same thing happens in 360-degree photos. Objects can also vary wildly in size, from a tiny security camera on the ceiling to a massive curtain covering a wall. To tackle these issues, they developed a framework called PAP, which is inspired by how the human eye works. Instead of looking at the whole distorted image at once, the system uses recursive visual routing to zoom in on areas of interest. It basically asks the AI to pick a section of a grid where the target object is likely located. Once a target area is found, an adaptive gaze mechanism takes over to fix the distortion. It projects that specific part of the sphere onto a flat plane, making it look like a normal photo again. This allows the AI to use standard recognition tools that were never designed for panoramic views. In the final step, the system uses a grounding pipeline to create a precise mask of the object. This identifies exactly where the object begins and ends so a robot could eventually reach out and touch it. The researchers found that this method significantly outperforms all previous state-of-the-art models. When looking at the statistics, this new system is especially good at handling hard cases. These include objects that are exceptionally small or objects that are split across the edges of the image. Standard AI models often fail in these scenarios, but the PAP framework handles them with ease. They also tested different ways to prompt the AI, finding that visual grid prompting was much more effective than just using text. By overlaying a grid, the AI can more easily pinpoint coordinates in a massive high-resolution image. The results show that adding a bit of logical, chain-of-thought reasoning also helps the system perform better. So, what does this all mean for the future? It means the next generation of robots won't have to constantly spin around just to see what is in the room. They will have global situational awareness, allowing for much faster and more efficient task planning. This could be a foundational step for home robots, autonomous vehicles, and even smart assistants in warehouses. By giving machines a 360-degree perspective, we are moving closer to AI that perceives the world as naturally as we do. Thanks for watching Summarize Science, and don't forget to look at the full paper for more details.